All right. Thanks, everyone, for being patient. All right, so I think audio is fine, but let me know otherwise. I'm also sharing my screen, so let me know if you can't see it. I'm going to be showing you a whiteboard now. Okay, so what we're going to cover this evening is hypothesis testing, but for proportions. So last week we dealt with the average, right? And how to do hypothesis testing when you have the average. So tonight we're going to work on proportions, and how it can be applied in the real world is, let's say you work for one of the mobile network companies like MTN, right? And then, as you know, there's competitors, there's Vodacom, Telcom, etc. And what MTN needs you to do is they need you to determine is the percent of MTN clients that move over to another network greater than 15%. Now, as you can imagine, if that percent is quite high, then that's alarming for the company because that means they're losing a big percentage of their clients, which is not great for business. So what their strategy is, before they can even implement a strategy, they need to determine is that percent, say, greater than 15. If it's greater than 15%, that's a problem, and they need to change something with their product or strategy, etc. Okay, but that wouldn't be your responsibility. Your responsibility goes as far as just determining whether that percent is greater than 15. If it's less than 15, if it's under 15, then they won't change anything in their business model, okay, because that's not an alarming percentage. So they'll continue doing business as usual. All right, so that's your job. You need to go and do this test, and it has to be done statistically based on data. And so that's where hypothesis testing for proportions comes in. All right, so I hope to give you an idea of how this is applied in the real world, but let's just look at this problem here to kind of put it into context. All right, so please, and let me know if you can't see the whiteboard, okay? This is assuming that you can. So it says churn is a term used to describe the rate at which a company loses customers to its competitors. And in the telecoms industry, it is believed that the churn rate between cell phone service providers is not more than 15%. Right, so I'm going to underline that because that's going to be important. We're going to have to use that later. It's not more than 15%. Okay. All right. Now, telecoms analyst, say that's you, goes out and looks at a random sample of 560 cell phone subscribers. So I'll underline that. Okay. And they found that out of those 560, 96 of them had changed service providers. 96 of them changed service providers within the past year. So what you did is you went out into the field and you only looked at a sample, okay? And the sample size was 560 clients. Of those 560, 96 of them changed service providers. So in other words, for this sample, the churn rate was 96 out of 560. That was the percentage from your sample, right? And that value is 0.17 or 17%. You can write it either way, it's fine. And we'll denote that by P because P is the proportion for your sample. All right, okay. Now, question A, is there sufficient statistical evidence at the 10% level of significance to conclude that the churn rate in the telecoms industry exceeds 15%? All right, and you need to do this hypothesis test and go back and tell your superiors that whether this percent is above 15% or not. All right, so that's what you're going to test. So as for hypothesis testing before, we have your 5 steps. So step 1 is to declare your hypothesis. So your two hypotheses are H0 and H1, with H0 being your null hypothesis. Okay. Now, they're telling you in the question to check that the industry exceeds 15%. So in other words, the churn rate exceeds 15%. All right. Now, exceeds means greater than. Okay. So with greater than, remember what we said last week? Of your H0 and H1, H1 will always take the strictly greater than or less than signs. So the greater than is going to be here. So the opposite of that is going to be less than equals to for H0. And remember last week we were testing mu, average, okay? But this time we're testing proportions. So the symbol for the parameter for proportions is pi, okay? And what we're testing is, does it exceed 15%? Or is it 15% and under? That's your H0 and H1. And if you recall from last week, if you didn't find out, refresh your memory, you need to state whether it's an upper or lower tail test. And as I mentioned last week, how I determine whether it's a lower or upper tail test, I look at the symbol for H1. Okay, now the symbol for H1 is the greater than, right? And I think of it as an arrowhead. It's an arrowhead pointing to the right. So that means if I had to do my rejection region, it would be on the right. So it's an upper tail test. That means the region is here, not on the left, not here, because the arrow is pointing to the right. That means it's this side. So that's my rejection region. Okay. All right. So this would be the test we're going to do for our hypothesis. All right. So I would make that statement as well. I would say upper tailed test. All right. That's step one. Now, step two. Step two is to construct your rejection region. Right? So I've already started sketching this graph. I know the rejection region is on the right. The size of this rejection region will depend on what your alpha is, or your level of significance, which is 10%. So the size of this region is 0.1. Now, if you recall what I said earlier, for hypothesis testing, specifically for proportions, that is pi, when we're dealing with pi, it's always going to be a z-test. If you don't have to worry whether you'd be using a t-test or a z-test. You will always use a z-test for proportions, okay? So we're going to use our z-table in the back of our textbook, which is centered at 0. So here's our table, all right? This is our standard normal table, the z statistic. Now, if you look at the diagram I've drawn on the right, I know the area to the far right, which is 0.1. But if you look at the graph in your textbook, the area that's shaded is not the extreme right region. It's the area between 0 and that cutoff point. So in other words, your textbook is giving you this area here, which I'm shading in yellow here. So your textbook will only be able to help you if you give it this area here that I'm shading in yellow, right? So we know this area in yellow. We can easily work it out. Remember what we said earlier, half of this area is 50%. So everything on the right of 0 is 50%. Everything on the left of 0 is 50%. Now, if I've already used a 0.1, okay, if I've already used a 0.1 here, and I've got 50% on the right of 0, so that means this is the remaining 40%, okay, because 40% plus 10% gives me 50%. So that's how I get my 0.4 here. Okay, because everything on the right of 0 must add up to 0.5 or 50%. So now I know this size of this yellow region is 0.4. I know the area. So if you look at your graph, your textbook, I know the area, which is given by inside this table, which is 0.4. I need to work backwards and figure out what is the Z value that corresponds to an area of 0.4. So I'm going to write this here. I'm going to look at working backwards and figure out what is this cutoff point here, given the error is 0.4. So if I look at my table, we'll go inside this table and look for a value that's closest to 0.4. And if you look, there's the value here. It's 0.3997. That's as close as you'll get to 0.4. This value is close, but it's not as close as this. So you take the one that is the closest to 0.4, which is this value here, 0.3997. Now, if you work backwards to figure out what the Z value is, then you follow the row going to the left, and you'll see that value that corresponds to it is 1.2, and the second decimal is 0.08. So the value is 1.28. Okay, so the value here is 1.28. So that's my critical value. So anything on the right of 1.28, because remember my critical region or my rejection region is here, I'm shading it in blue, right? So anything that falls in that rejection region, that is anything that's above 1.28, I would reject H0. And anything on the left of it, I would accept H0. So anything on the left of that, I'm going to accept H0. All right, let me check the chat if any questions. Okay, so far so good, but do let me know if you have any questions, all right? Okay, so I'm going to come back to the board. All right, so now I've done step 2. Let's move on to step 3. Now, step 3, I'm just going to change the color. All right, step 3 requires a bit of working. I would say step 2 is more work than step 3, right? Step 3 is just plugging values into an equation. Step 3, you need to calculate the test statistic. All right, so I'm just going to make some space on the board here. So remember our P is equal to 0.17, right? We worked that out. I'm going to remove this. P is 0.17, so I'm just going to write that. P is 0.17. Okay, now we're going to go to step 3. You calculate the test statistic. Now for proportions, you're given the formula in your formula sheet. And the formula is Z test equals, now you're working with proportions. So you look at the formula that relates Z to pi. And if you look at your formula sheet, you'll get this formula here. You don't have to memorize it. I'll write it out, but it's in your formula sheet. It's P minus pi all over square root pi into 1 minus pi all over n. Now we have all the values we need to plug into this equation. There's your P, so you're going to plug in 0.17 where we see P. For pi, you would substitute the value that you have in your hypothesis, which is 15%. So you're going to substitute 0.15 or 15%. Your n in the formula, it's here. That's your sample size, 560. So you have all the values to substitute into this formula. And if you do that, right, after you plug in all the values, you'll get a value of, I'll write it out, is 1.33. 1.33. So that's your test statistic. So that's kind of the bulk of your calculations. All of them are done. Now it's a matter of interpreting your results. You've done step 1, step 2, step 3. Now, I'm going to ask you this question. Based on the results you got in step 3, which is 1.33, compared to what your rejection region is. Is it above 1.28? If so, do you reject H0? Is it below 1.28? And if so, do you accept H0? So what is your conclusion here? Based on what you got in step 3, you got a value of 1.33. Looking at what your rejection region is, do you accept H0 or do you reject H0? Can you write that in the chat? Just I want to make sure that you understand how to make a conclusion here. So are we rejecting H0 or do we accept H0 based on the result in step 3? Good. Vanessa, good. Okay, let me know if you don't understand why you're rejecting H naught. But you can see your test statistic, 1.33, it's greater than 1.28. So that means it's on the right of 1.28. It's somewhere here. We don't have to, we don't have to be exact. We just know that it falls in the rejection region. Okay, it's somewhere there. So we reject H naught, and that's your step 4. Step 4, we reject H naught. And now that you've done this, you can go back and tell management what your conclusion is. So we're rejecting H naught. Okay, so rejecting H naught, that means this is not true. So that means this is what we're going to report back to them on. So we're going to tell them at a 10% level of significance, okay, the churn rate is above 15%. So that's a worry for them. Remember, the problem would have been if the churn rate is above 15%. We don't want the churn rate to be high, but the evidence, the statistical evidence, is pointing towards the churn rate being above 15%. Okay, so we would try to write it out. I'll write it out properly. This is the official conclusion that you would wrap this problem up with. Which is just step 5. Okay, so step 5. Okay, let's make a conclusion. So remember what I said, always start with your level of significance. So we would say at a 10% level of significance, there is enough statistical evidence to show that the churn rate is above 15%. That's how you would conclude this problem. Okay, remember to always state your level of significance. And it's important because if your level of significance was, say, 5%, that could actually change the result. You could actually be accepting H naught. So it is dependent on your level of significance, which is why you need to state that. Okay, are there any questions? Does that problem make sense? Everyone understand that? That is pretty much the end of Learning Unit 8. Thanks, Vanessa. So that's the content I wanted to cover for Learning Unit 8. So remember, to sum it up, we've done hypothesis testing for averages. For averages, you can either use the Z test or the T test. Okay, so I'll just kind of wrap it up here. Okay, so we have hypothesis testing in Learning Unit 8. Okay, and with that, you can either be testing for the mean or you could be testing for proportions. If you are testing for the mean, it could either be a Z test or it could be a T test. And you need to figure out which test you need to use. Okay, if you watched last week's video, I showed you how to identify that. If your sample size is below 30 and your sigma is unknown, then you would use the T test. Otherwise, you use the Z test. So make sure you familiarize yourself with that. For the proportion, there's only the Z test. Okay, you'll always use the Z test for proportions. And this is what we've covered today. And that is Learning Unit 8. Okay, so please do go to the recordings if it will help you again. I'm going to make a practice test available, which you can try out. The marks don't count for anything, but it will help with your revision. And I've also revamped the resources under lecture resources for this learning unit, as well as the learning units before this. So you can go through it when you're revising. So do give it a shot. Let me know if you have any questions. But I hope the content that I've covered this evening has made sense. And next week, we will kick off the last learning unit. which is Learning Unit 9. All right, the floor is yours if you have any questions. Otherwise, thanks for joining everyone and have a good evening.